Hello, it's Brad Laurie, or Blockchain Brad, and today I'm speaking with someone that is well known for his tech savvy, his tech knowledge. He is leading out all of the technological aspects of Perlin, and his name is Kenta Iwasaki. Kenta, thank you very much for making time to speak with me today.
My pleasure.
Now, for those who don't know Kenta, he has a long history all the way back to when he was 10 years old in technology. He's chosen the blockchain to really focus on building things out, and he's chosen Perlin specifically to be part of that team. We're going to find out why. This interview is all about exploring the depths of the tech. So if you're interested in the basics, the fundamentals, and more of an overview, this is not the video for you. This is really diving deep. So Kenta, thank you again, mate, for your time. Now, we'll just start with a few basics for a start. Powering the future of trade is the slogan for Perlin. Can you just give us a quick rundown on just your interpretation of Perlin for those who perhaps never heard of it before?
An interpretation of Perlin. So, I mean, we've kind of got two whole aspects going on here. One is the more enterprise-related solutions, and the other side, it's heavily focusing on technology, because in the crypto space, we obviously are not seeing enough technological development nowadays. That sort of Perlin, from the tech point of view, we're a group of developers. We've prided ourselves with open source development work from as early on to the point where we're perhaps 10 years old. So we're an extremely passionate group of developers. We work in a number of different industries, and our goal here is to sort of bring what's missing from Bitcoin, what Bitcoin, Ethereum, a lot of these projects realize they have been missing, into production and into the hands of developers as of today right now, so they can build some actual decentralized products or services with ease.
Right, and I think it's just some very important terms there, actual. And we're going to explore this in all of the code that you've built with your team. You really want to be that genuine utility to bridge the gap between the mainstream and the blockchain. So please continue on. And can you mention as well a bit more about the enterprise aspect as well, the potentials of Perlin in the context?
Oh, yeah, most definitely. So in the case of the enterprise solutions, one of the biggest things we've noticed is in terms of trade finance, right? There's this bill, the Bill of Ladings. They sort of describe exactly what sort of amendment, what sort of commitments two parties have when it comes towards creating or performing a single trade. The thing is, though, that these Bill of Ladings, they were created by the ICC tons of years ago, and they still govern all of the trades, most of the trades today, using just paper. So all these Bill of Ladings, they're still printed on paper. They've got lawyers checking through every single little bits of details. And as a result, trades commence extremely slowly, but at the same time, they sort of facilitate a very inefficient process.
Right, so we're dealing with archaic laws for a contemporary time.
Exactly. So that's where we kind of step in then with our enterprise solutions, where what we're heavily focusing on right now is trying to introduce new standards into the world, standards specifically that can actually be made virtual, considering the amount of technology that we've got nowadays, alongside the new technology that we're developing over here at Perlin. So in terms of paper, well, basically we're trying to go on and making it smart contracts. We're trying to automate this entire trade process, alleviate the billions of dollars that are spent on a monthly basis just to perform these trades, so that overall, the world can just run much more smoother on a single interoperable basis.
Yes, and we're going to find out exactly how with all the different aspects of the ecosystem that is Perlin, specifically with your distributed ledger as well. But can we talk about some of the other claims for a moment? Now, one of them is that Perlin wants to be the world's fastest blockchain. Clearly it's confident it is such. You're the lead technologist. How can you be sure that you're on track to make that claim?
So our benchmarks, we've gotten 31,240 transactions per second. More specifically, those transactions are payment transactions. The reason why we're making this claim, we've done very thorough benchmarks. And as a matter of fact, for any developers out there that are very interested in reproducing these benchmarks, we've provided all of the open source code, gave all of the details necessary so you can actually reproduce them for yourself for the sake of assuring whether or not Wavelet as a ledger is actually able to perform those kind of standards or limitations that we have specified. There's a specific sort of details of the benchmark setup was that we had 240 nodes on a digital ocean. They have to be consumer grade spec, so they have 4 gigabytes of RAM, two virtual CPUs, which is actually even less than a modern consumer laptop nowadays. And we've even simulated an extremely rigorous sorts of network settings where, for example, communication between two nodes has a latency of approximately 220 milliseconds. Okay. We've ensured that we considered what if there was about a 2% packet data loss between two nodes every single second. And also we limited the transfer bandwidth rates to sort of simulate, those sort of geolocations where they don't necessarily have the best bandwidth in place to about 1 megabytes worth of data per second. So all of these extremely rigorous benchmark conditions, that's how we eventually came up to measuring that our ledger is able to sustain 31,240 transactions per second.
And I think that's your secret sauce, to be honest. Having looked into this a bit more with your code, you can go into the open source repos as well. This Wavelet distributed ledger really is the benchmark for all ledgers. So we really need to explore that in depth today, because you've spent a long time. How long have you been working on Wavelet for, which is the distributed ledger?
Oh, it's been about a year, I'd say. A whole year, but we've got it extremely far with Wavelet as right now. Every single working day, like improving the product, called rebuilding the code base. We've rewritten the code base about 10 times.
Right, and you've been in stealth. Can we talk about that? Because the people will want to know why. Perlin hasn't done a lot of PR, these recent months. Any reason why?
The biggest reason why is primarily because when we go about releasing a product, we're looking at it from more of the developer community point of view, where we're working with some huge enterprises here, governments, in fact. We want to provide them standards that they could actually look up to and enjoy using to then create the numerous amounts of standard interoperability layers they choose to make, whether it be political, within the industry, etc. So in order to get that sort of highest quality out of all of our products, that's pretty much why a great majority of our development has been in stealth. That being said, we're sort of taking the next steps right now. And now that we finally finished doing our 10th rewrite, we are more than happy with the product code, more than happy with all the code. We're going to be open sourcing the entire Wavelet ledger and all of this work that has accumulated in the midst of the period that we have been in stealth to you guys pretty much today.
Oh, okay. That's a big deal. So Wavelet's hitting the blockchain as a mainnet. It's open source. Everyone's going to be able to experience this completely. This is a long roadmap that you've had built in to get this far. It's a big deal. Yeah,
it's been crazy. I mean, each individual little subsection, like whether it's the protocol layer, the code, any single one of those, it's been extremely strenuous on how exactly we're ensuring that Wavelet meets the highest standards of everybody. I mean, there's still work to do, of course. We've acknowledged that, but it's time that we come out of stealth. We start growing up the community and start having them actually get all this access to what Wavelet can really bring to the table for people's products and services.
Yes, well, we're going to find out from today onwards as well. And what's interesting also is that you're the sort of personality, having known you for a while, Kenta, that is a perfectionist. You don't like to release anything that's not perfect. There's no such thing necessarily as perfect code, but you've really made an effort to bring the best of what you can do. And as someone who has been coding since you were 10, that's quite remarkable.
Since I was 6, actually.
Okay, even more crazy. I mean, you're definitely a child prodigy. You know what you're doing when it comes to computers, when it comes to every aspect of coding. But let's explore in detail a little bit more about Wavelet, because this is the big focus right now. Now, one of the things is that you mentioned before, you're confident, but we'll talk about Avalanche for example, for a start. Now, you utilized other technology, other code to really, develop your own. So again, you make the statement you're the best in the space, but you did use others. So let's talk about how you did. What was the process?
So just to actually give a little bit of an update, the latest Wavelet ledger right now, this is not even a blog post release yet. It does not use Avalanche anymore.
Okay.
We've completely stripped off Avalanche. But I can tell a bit of the history on how the protocol sort of developed in place. The original Perlin motive, it's still our motive today, is to build a sort of decentralized cloud to sort of allow people, empower the fact that they have a mobile phone or a laptop available to bring them universal basic income. In order to be able to leverage that, it's got to be a decentralized service. We were figuring out what public ledger could we use right now that is performant enough to be able to meet the demands of our decentralized cloud computing platform.
Mm-hmm.
None of them existed during the time that we made it, the company being December 2017.
Mm-hmm.
So we looked at all of the alternatives, looked at, there was no software, no open source implementations available, but there was a proprietary one that was pretty interesting, being Hashgraph.
Right.
So Wavelet evolved all the way from the beginning as a Hashgraph implementation. And we noticed that inevitably, Hashgraph did not make the cut for us because actually it's extremely difficult to bootstrap it to work within a permissionless environment.
And I think we need to stop there for a moment because the DAG structure is what underpins Hashgraph. Is that correct?
Right. They have the whole concept of gossiping about gossip, which a gossiping protocol is extremely fast. You're able to deliver messages, and the messages being transactions in this case, to a huge network extremely quickly at the cost of huge bandwidth waste. But then the way their consensus protocol specifically works, the only reason why it works in a permission setting is because you must know the number of nodes in the network. To change membership, to let new nodes join in, or to let old nodes come out of the network, that's not very clear or very trivial to do with Hashgraph's current protocol specification.
Right, and also because they were permissioned in many respects, there was a degree of top-down control, there was a closed environment, and in many respects, it's a bit like a database functionality.
Right.
So you're trying to flip that on its head with a permissionless system and utilize DAG in a new and novel way.
Though that unfortunately didn't work out. So we scraped the whole Hashgraph approach, and we were looking for others within the market. That's when we stumbled upon Avalanche. Avalanche was the second ledger we tended to. We wrote an implementation out before Avalanche even got popular. It was Emin writing a tweet with the white paper. We took it and we're like, okay, that looks pretty interesting. We'll implement it out. 3 months in, we've already got a full implementation working. We were hitting about 10,000 transactions per second. And at the same time, we solved a lot of unclear little tidbits that were very vague within the Avalanche white paper. Specific things that were vague was how exactly would smart contracts be supported? So here's one problem with Avalanche. Avalanche only guarantees what you would call a partial ordering of transactions. By that, basically, you have a bunch of nodes in the network. Each individual node, they would see the exact same set of accepted transactions, all right? So transactions that are accepted within the network, each individual node will have the same consistent set.
Okay. But
here's the thing. What they mean by a partial ordering of transactions, the order in which those transactions were applied, so the set gradually gets built up as consensus finalizes these transactions. The order, however, in which they are finalized is different for each and every single node.
Right.
So think of it like this. The whole, say I deposit $1,000 into my bank account, and then afterwards I'll send you $1,000. To some nodes, it's I sent you $1,000 first, and then I deposited $1,000 into my bank account.
Sure. It basically creates a massive inconsistency across the board.
Right. Now imagine smart contracts. They're programs, autonomous accounts governed by code. If the order of operations, the steps taken to create a new CryptoKitty were different for every single node, there would be so much inconsistencies across the network that it's just not viable. How could that protocol support smart contracts?
It's basically looking at a spider's web and then taking away some of the strands as you go and then realizing what you have at the end. That's more of a metaphor of it because it doesn't have a full and replete conduit that is balanced. It is total by design.
Exactly. Yeah. So, I mean, right. And that's just one of the problems. There was a second problem. How do they use proof of work or proof of stake? The general definition of a ledger, a public ledger, for me is one is a consensus mechanism. The second one is a SYBIL resilience mechanism. SYBIL resilience, it's how do you assign weights or how do you consider which nodes are more powerful in terms of making decisions or voting for a transaction to be finalized? What mechanism do you use in this case? It's usually proof of work or proof of stake.
Yeah. Well, in your case, it's proof
Yeah,
of stake from what I've read. So that's the
exactly.
exciting
Yeah.
thing. Let's talk about that because that's been a new flavor for Perlin, a new addition,
Mhm.
moved away from some of those initial implementations and designs. So what does it mean for you now as you've moved on from Avalanche as that second sort of exploration?
So, I mean, overall, we built a fundamentally different protocol over to how Avalanche works. But actually, within this new protocol that we've made, we do reference one small little protocol that is specified within the Avalanche white paper. That protocol is called SNOWBALL. SNOWBALL is a binary consensus algorithm, which means that if you've got a bunch of nodes, um, you need to make them decide on one true object that everyone consistently knows about over a bunch of possible objects. So say I have a bunch of conflicting transactions. What this protocol does is it lets me pick one transaction to be the solution to the conflicts in this case. Wavelet bootstraps this on top of this and introduces a completely new DAG construction, which is actually why Wavelet nowadays is able to scale to those 31,240 TPOs that I was talking about.
Right.
And on top of that, introduce a new proof of stake construction as
Well,
well.
Emin would be happy because you've utilized something from his with the snowball, coupled that with proof of stake, and really built something
Yeah, definitely.
completely
Kudos to Emin, Team Rocket
Mm.
for their work. But I do have a criticism of the Avalanche white paper, apart from the vague
I've
details.
read some of the comments actually from you, so I know you do.
It's just the mathematical proofs. You show this to any academic in the distributed system space. Actually, we were working with academics uh, to create this new wavelet protocol. The academics names Dimitri Papadopoulos from Hong Kong University of Science and Technology, Folteni Baldinci from George Mason University, and also Joshua Lind, who is the author of T-Chain, which is a sort of a scaling solution over for Bitcoin, or from Imperial College. So we're working with academics here, and even like reading over this paper, this Avalanche paper, the mathematical proofs they use have way too many assumptions behind them. Basically, that means that if you go on and put this consensus protocol out in the wild, if any one of those assumptions accidentally gets violated, the whole protocol comes crumbling down into
Right.
a
So
mess.
almost like overzealous theoretical propositions that hadn't
Exactly.
really been, again,
Yeah.
empirically tested or moved out into testnet phases even at that point. You're
Right.
way ahead in that sense now. And let's talk about that because fast forward a year from the theory, when you finalize this, you now have first and foremost a mainnet. What was it like to go through the testnet phase of the alpha to beta in terms of building this, especially in the context of the code in the way you've compartmentalized different parts of Wavelet?
Oh yeah. Okay. That's a whole another journey of its own.
Right.
But to step a little bit back, we're still using Snowball, right? So I had to justify why was Snowball working. Actually, I wrote out a combinatorics proof to actually prove why Snowball is working. That was much more rigid than the proof that was provided in the Avalanche paper.
Okay.
Yeah. Just so we can be sure that Snowball is actually a safe consensus protocol to use within.
Yes. Well,
Wavelet itself.
how has the testing gone? Because once you made that decision, obviously you've had a lot of peer, or would imagine you had your colleagues review this, but you've also built it out yourself. So what's the process been like in terms of making sure that everything is operational for the main release?
Loads and loads of stuff. It was tests. It was the rewrites of the code. So the reason why there was 10 rewrites, it's the changes in protocol contributed for one. We are also from the very start, we wanted to open source the project. How would other developers onboard into the process so that we could create a technical community that's able to then contribute towards developing out Wavelet for the future? We had to. This was considered quite often, such that as we were constructing the code base, there had to be no vagueness. There had to be no sort of difficulties or intricacies that developers could not understand from the get-go reading our code.
Okay.
And I guess going from the testing process, we spent an extensive 2 to 3 weeks writing out large lump sums amounts of scripts to perform fuzz testing. Fuzz testing is basically like you've got a function, it's got parameters, And then the fuzzer would basically go about permutating and trying to figure out what potential input data to your function would cause the program to crash. So
Right.
resiliency against crashes, resiliency against memory leaks, against DOS attacks.
Mm-hmm.
We had to take that into account as well as we were developing out the ledger, which easily took 2 to 3
So
weeks.
basically testing for attacks and bugs or any potential risk and harm.
Yeah. And we've also got like a security auditor on board to do a second round of testing with us.
Wow.
As well.
So you spent a lot of time on this. Now, with regards to some of the additions in terms of languages, developer languages, you've really improved that. You've integrated WebAssembly, for example, and you've got Rust. Yeah. Let's talk about how robust you've made this how accessible you've made this for developers worldwide.
So WebAssembly, naturally, there's a lot of conflicts of interest with WebAssembly because as an assembly specification, people think, oh, we should just limit WebAssembly to being an assembly standard for representing programs to be ran in the browser. But arguably, like even for Mozilla, sort of stresses this quite a bit. It's just supposed to be a safe assembly standard where you can run WebAssembly programs no matter what sort of environment you really are running the program within. So for smart contracts, it's obviously a natural fit in this case because smart contracts, they need to be programs that can be ran with peace of mind, knowing that it's not going to do anything to somebody's operating system. So we've went out of our length ways. We've developed our own WebAssembly virtual machine. Kudos to one of our core developers, Heyang Zhou. This virtual machine, which we call Life, effectively acts as a very extensive sort of virtual machine for WebAssembly, like no other. It's fast, not necessarily the fastest in the market by any means at all, though its whole sole purpose is to allow developers to incorporate and execute WebAssembly, knowing for sure that it is incredibly safe. It does not expose any sort of bugs, any sort of faults towards those who do run programs with Life in this case.
Right. And so it's called Life. The WebAssembly is the focus. That's built into as one of the many core features that you've included in this suite. I had a look at them and they're all itemized. And one of them is, they have interesting names too. Obviously, you've explained it with Life and with Wave. If you'd like to know more, obviously go and read about them. Because of this interview, I don't want to spend too much time, but certainly WebAssembly is built in. Now, let's go back to Wavelet for a moment. Clearly, fast, secure, arguably one of the better, or if not the best, distributed ledger that exists now. But let's talk about the potential of this in the real world. Now, you guys say that you can do Visa-like finality. You can form, and do multiple millions of transactions comfortably with the ease of scalability in mind. So give us some examples, with your test, what you can actually do if someone's looking at this from a non-crypto, concept, from a non-crypto understanding, what you can actually do.
So actually for Wavelet itself, I mean, I can just straight out list what are the exact benefits of Wavelet compared to other ledgers within the market at the moment. One is scalability, 1 to 4 second transaction finality latency for 1,240 transactions per second on via rigorous benchmarks. So speed, it's not a problem at all. You want to deploy a smart contract, it's incredibly fast, and you can incorporate it into whatever sort of decentralized products or services you choose to build. The second thing is practicality. So developers don't like solidity.
Well, you're a developer. You have that knowledge, that code. So, that's a big statement coming from someone like you.
When it comes towards building a programming language, usually people would expect their programming language to be used for things a lot more than smart contracts. Smart contracts is just one of the many niches of application development compared to all of the other things out there. What about developing operating systems? What about developing backends, front ends, databases, etc.? People would much rather learn a general purpose programming language. So there's a huge adoption barrier, being that developers are uncomfortable with using decentralized tools. And no matter how much effort is made in making those kind of tools, it's just incredibly hard to sell them to developers.
Well, the good thing is you didn't go and make your own language like Ethereum did. You didn't go and create a Solidity version of Perlin.
For me as a developer, I'm comfortable using my IDEs, my editors, my debugging tools.
Mhm.
I don't want to go about learning something new, potentially buggy, because it hasn't had the maintenance. All of the tools I'm currently using have had for the past 20, 30 years.
Right. So what do you do instead with Wavelet? How do you approach this, challenge of being reasonably open to the best languages that exist?
Simply by using WebAssembly.
Mhm.
So one of the best things about WebAssembly is that a great majority of programming language communities are looking to adopt the compiler backends of these programming languages, Rust, C, C++, and allow developers to opt in to compile their Rust, C, C++ code into
Mhm.
WebAssembly.
Okay.
So naturally, now you can use all of these languages that a lot of people know and love,
Mhm.
and build applications like the usual, debug them like the usual, create test cases, do all the extensive testing practices that we all know and love all the way back from the 1980s,
Mhm.
and now use them to make smart contracts.
Right. That makes a lot of sense. So now basically it's the gateway. The WebAssembly
Yeah,
is such, and it really gives everyone an opportunity, an equal footing, regardless of which preference of developer language they like.
exactly. So Wavelet's a plus in developer adoption in this case, but
Mhm.
there's one more aspect of Wavelet that is very, very interesting, and it's user adoption. User adoption is a very big critical topic that I would say, I'd argue Bitcoin and Ethereum does not really look or seek to address at the moment.
Mhm.
And I talk about user adoption from the standpoint being, how hard is it for me or for anyone as a typical layman to create an Ethereum full node? If I want to participate in the Ethereum network, how difficult is it really for me?
I would imagine it's quite difficult.
There's only about 800-ish full nodes for
Mhm.
Ethereum right now.
Right.
Now, if you count the number of light clients, which are relatively insecure, there's millions of them deployed out there in the world today.
Mhm.
So the reason why people, even MetaMask, it's a centralized solution right now.
I see.
So, this
So
is
that
kind
that
of,
to you is the problem that really incentivizes you to build this whole ecosystem of Perlin,
yeah.
because you
How
want to
can we
change that
get,
narrative.
exactly, how can we get people's laptops and phones to participate, to contribute towards the safety, the validity of a blockchain?
Hmm. So you're
What?
backing
Yeah.
back mapping from use case. So talk us through that more, Kenta, because that's the most important thing. If we're going to see Perlin succeed and it's going to have adoption via real purpose, talk to us about how the tech correlates with this. Like, try and
Mhm.
really clarify to us, because obviously you have the tech knowledge of what you built, but how does it translate in the real world?
So Wavelet's protocol in itself, it's constructed as a directed acyclic graph, as a DAG.
Mm-hmm.
We've introduced a new sort of mechanism which allows you to, from the bottom to the top of the graph, finalize portions or chunks of depths of the graph. And this sort of finality is not probabilistic. It's actually irreversible and immutable. This is very different from what you would see on Bitcoin, which is much more probabilistic in terms of consensus or finality in this case. There's a chance that transaction can be reverted. When
Okay.
a transaction gets finalized in Wavelet, it does not get reverted.
So
Unless,
final means final and absolute.
yeah,
Okay.
it's absolute.
Mm-hmm.
And when this happens, uh, knowing that these transactions are most definitely finalized, you don't really need to care about them anymore. You could, for those perhaps who are maximalists when it comes to security, probably they can archive them somewhere.
Mm-hmm.
But for a lot of day-to-day purposes, people don't care about keeping all of those transactions within their hard disk. They could, Wavelet lets them throw all of those transactions away. Transactions that are finalized don't need to be kept in memory or on disk anymore.
Right. Now, if you can do that, you must be getting the attention of all the enterprises right now and all the government. I mean, there'd be a huge demand for this because of the complexity of this, but yet the beauty of its simplicity, its functionality. And again, it's reframing the whole model of cryptography built into blockchain.
Mm-hmm. Right. And basically, like with this being possible,
Mm-hmm.
you could effectively run a Wavelet full node using just your smartphone.
Okay.
So we're able to lower the system requirements, the amount of effort it takes to actually be able to participate in the Wavelet network to the point where people could just plug in their laptop and become validators of the Wavelet network.
So
and
how
this
many
is
could you cope
accompanied
with? How many could you theoretically cope with in a very
as many as you want.
Right.
So we also introduced a whole new proof of stake protocol. It's the only one in the market which is leaderless. And why I emphasize this is because when you look at all of the current proof of stake ledgers out there right now, there's this notion of a committee.
Yes.
There are these validator committees. There are the 21 block producers, 1,000 node committees. There's some amount, right? And that actually poses as a problem over to the average layman. Say, you know, I want to become a validator. I don't have that much money, so I'm going to go and pop in about maybe 5 ETH. That's a big lump sum of money.
Right.
What are the chances of me getting into that committee?
Pretty much zero.
That committee gets rotated every maybe, let's say 20, 30 minutes, something like that. The chances are very, very small. I'd basically be bargaining or trying to fight against the top 10,000 most richest validators within the network.
Right.
To get a gleaming chance to then be able to get a validator reward. So I'm going to have a near zero chance, right? That in itself causes a lot of problems. So in Wavelet, we sort of refactored this sort of methodology and how proof of stake is actually done, so that as long as you stake a small amount of pearls, or cryptocurrency in this case,
yes,
you could actually start participating in validating the network and actually reap rewards. So no matter how small you are, whether you're a student or you're a billionaire, you can still participate in Wavelet and make lump sums amounts of money.
So it's truly an equitable design, a truly equitable token. This hasn't been done from what you're saying before, in the way in which you can stake and get rewarded with the smallest increments, the smallest amounts that you can contribute to the network.
Exactly.
What's really interesting is the mode of access is via the phone. So let's talk about that in context with those who typically wouldn't have anything but a phone. This is really important because right now we see the advantaged and the privileged white collars, actually, in many cases, really to making the most of cryptography, blockchain, and all of the different financial incentives offered. But this is an opportunity for something very different.
Exactly. So actually, there's a bit more than, so specific, the actual system specifications you need, it's 512 megabytes of RAM. Most smartphones have that.
Okay.
You also do need a healthy internet connection. I guess that is one questionable sort of point of barrier. But there's nothing you can really do about that. You just need a decent internet connection.
But that is improving over time, though, to be fair, because as we become more globalized, we tend to have better access, and that should be a reasonable expectation for most regions as they develop. And we're certainly seeing that in regions that haven't developed before, and things like this potentially could make these regions be more economically viable. Just this access alone could literally change their economies.
Right. So all in all, I mean, in that case, all you've got to do, you run the Wavelet app, you click a button, you start participating in the network, you're validating transactions, and there you have it. You get paid. There's no there's a chance that I might get 5 pearls 2 hours later if I get lucky in being part of a committee. There's nothing like that.
Right.
It's proper decentralization.
Really cool. So anyone with a phone anywhere in the world from today.
So you could even argue this is even a much better approach than proof of work. In proof of work, there's still people complaining about using the right hash function, about complaining about Bitmain having all these computational resources available to them so that they can
latency. It's ongoing.
Exactly.
Well, you've
at this
done
point
a lot.
in time.
Well, there's a lot you've done. Can you give us some examples that you're aware of, having spoken with your CEO, Georgie, just the context of applications, for example? I've read through them. It's immense. The strategy you put in for some of the dApps, for example, because people don't perhaps understand. You also, being an ecosystem, you have applications that build onto Perlin. And they're relevant in this context because they're some of the use cases that you're starting with.
Right. So we've got a whole slew of products. In this case, it's Clarity, it's Clarify. Stuff basically having to do with supply chain management. That's one of the biggest problems right now. Huge lump sums amounts of money is needed to be able to sort of get that sort of transparency you need in running a supply chain management business that and there does not really exist any viable approaches towards creating one without spending billions of dollars on it. So in this case, Wavelet, I mean, there's a huge amount of applications when it comes towards tracking assets, when it comes towards creating standards and political frameworks, when it comes towards even just writing a decentralized social network. From the small use cases to the big use cases, the point is Wavelet makes lives simpler for developers, for startups, for enterprises, to actually start reaping the benefits of what it means to have your products or services really be decentralized.
And could it even extend to, those major conglomerates, corporations? I don't want to FOMO, but this is exactly what I'm hearing from you though, Kenta. The kind of technology that Wavelet offers, it's surely got to be interesting to these major players in economic design and economic development, and even to really reframe some of the centralized governance systems of their business models. And it seems to be that Wavelet is the secret sauce quite seriously, not just for Perlin, but for the crypto ecosystem more generally, because it's really so innovative.
I would argue not even just the crypto ecosystem in itself, even the decentralized ecosystem in general. So think BitTorrent, think Open Bazaar, the whole sort of the next eBay, the next decentralized eBay.
So why
Wavelet
don't people,
acts as a...
why don't people know more about this? I just find that remarkable. Why aren't more people
There's a reason
Wavelet?
we've been in stealth, right? That pretty much answers that question. I mean, this is the point in time, now that we're releasing everything, where we're starting to make a sort of big move on and start developing, start onboarding the right people to then get all of these sort of new decentralized apps going, all empowered by a Wavelet.
Right, and I apologize for interrupting. That was rude of me. But you were talking also about, you were explaining, thinking of eBay and other ecosystems beyond crypto. Can you keep on with that discussion, because it's quite interesting about how
it's basically just like the sort of applications I was thinking about is something like Open Bazaar, Mastodon, Matrix, even like Telegram in a sense. Right. So all of these sort of ecosystem, these sort of applications, they require some sort of decentralized backbone. They each individually have their own, but it's time we just have a single standard base that everyone can build on top of. I mean, decentralized apps, they even have benefits outside of the whole sort of political spectrum, the whole crypto anarchist point of view. It has major benefits towards solving a sort of huge computer science problem that has been going on ever since the dawn of time, since distributed systems started. It's that how it's extremely, extremely difficult to actually create an application that is resilient, something that can stand the test of time and never go down. Even Google, Microsoft, Amazon, Microsoft, they have applications. Cloudflare went down just 2 days ago, and about 30% of all the sites in the world just shut down. So this is where decentralized apps, where we're trying to remove single points of failures out of applications. That's the next step for us, actually, even in general, for creating new kinds of web products, new mobile apps, etc. And that's actually, to me, the main reason why I got interested in blockchains or distributed systems in general.
Well, what's interesting also is that initially everyone who was involved in cryptography, involved in blockchain, had that premise. But right now, for the financial benefits of having a more distributed system, many of the top-down parties, the enterprises, obviously with Perlin's relationship with them, are paying attention for the financial benefits of that because of the costs of these centralized failures. So it's interesting that all the efforts you've made to address the issues of SYBIL attacks, you've moved on, as you said, from those initial iterations, beyond from metastable, avalanche, all of that's been scrapped now. You're focusing on specific aspects. You added in rewards, incentives for everyday people, and regardless of that. I mean, these are pretty major changes you've made. But then I wanted to talk to you a little bit more about what you regard as topological sorting. You were alluding to this before, ordering of transactions. Okay. That's interesting with regard to cost saving as well.
Specifically topological sorting? I mean, topological sorting, it basically...
with regard to transaction costs, because often when you have a system built in where the transactions are recorded in such a way where depth isn't an issue, it's expensive. But what you did is you looked at everything from a depth approach when it came to transactions. So in that
Oh,
respect,
like basically structuring everything up as a DAG.
mm,
I mean, so blockchains in itself, if you look at them in general, they actually are directed acyclic graphs in themselves, though structured in a different ways. Directed acyclic graphs in Bitcoin, so they exist in Bitcoin and Ethereum. They represent conflicting forks.
mhm.
So each conflicting fork is a path inside a graph, and then afterwards you got these transactions scattered between them, and sometimes forks could merge or diverge, etc.
Right.
Basically, like with the construction. Going back to Bitcoin and Ethereum, what they do with these DAGs is then they implement what you call a fork choice rule. Maybe it's the longest chain, the chain that has the most amount of contributed computing power or stake associated to them, that gets selected as a one true ground source truth chain that everyone follows in the network.
Hence, we have the blockchain.
Exactly. So it's one single chain. So it's trying to draw a path out of a graph, and then that's the main ground source of truth. DAG ledgers basically go all the way back to step one, square one, look at that graph one more time, and invent new kinds of heuristics, new kinds of fork choice rules, such that nodes can actually come to consensus much more efficiently, much more quickly in this case. So our approach, going for the whole approach now might be a little lengthy.
Yeah, well, maybe we should. But what was interesting, though, is the ordering specifically, the way it was told.
Right, exactly.
Very direct, like you were saying before. That changed everything.
Exactly. I guess a very sort of simple, high-level version of the Wavelet protocol is we basically, you have the graph, you've got two defs, a starting point and ending point. And what we're going to do is we're going to take all the transactions within that def interval. And what we do is we then perform a topological sort from the start to the end, find all paths between the start and end transactions, and then mark those. And the topological sort is unique in this case. It's less graphically least, so it's even more unique in this case. And that essentially is what we use to sort of achieve consensus and guarantee a total ordering that is consistent amongst all nodes within Wavelet. And
why is that cost effective as well? I think that's important that people understand in terms of transactional costs.
All right. So when it comes towards, so we'd have to look at Bitcoin. Why is Bitcoin expensive in this case?
Right.
You've got a longest chain. There might be similar sized longest chains to the side, like maybe one less. People are appending blocks on either one of the many available chains out there. And you can think of it like a battle where you've got these two chains and people are appending blocks on these two chains, and then one of them is going to supersede the other. But the thing is then, like, we can consider those two forks to be conflicting, right? How long is it going to take for those forks to resolve itself such that one of the change is dominant over the other one? And the thing is, proof of work is not cheap to make. It's actually very expensive. This conflict resolution mechanism takes exponential amounts of time.
Yes, and energy, and literally.
Yeah, and blocks get made. That's going to increase the transactional cost.
Right. So by doing the topological, basically, in a nutshell, you remove all of that from the equation to make it more simple, more streamlined.
Exactly.
Okay. Now, if you'd like to know more about that, make sure you look into Kenta's notes. I've read a few of them. There's a lot more there. But the whole idea of this is to open up all the tech. So once again, this is trying to be a tech deep dive, and I'm trying to keep up with Kenta, but there's just no way. And his brain is really second to none in this technology. Now, with regards to some of the graph synchronicity, I did want to touch on that because that's interesting, and also looking at your overlay routing as well. Because in your articles.
So we specifically use a Escademlia overlay network.
Okay.
So Escademlia, I mean, it's basically just a sort of, when you think of an overlay, you think of a system that sort of is the base layer for all intercommunicate. An overlay network is basically a base layer for all intercommunications across nodes. Because the thing is, when it comes towards peer-to-peer networking, we got to be sure that peers can't learn too much information of a specific peer to potentially take them down or, do horrible malicious stuff to maybe high-powered or low-powered actors.
So you embed a bit of privacy in there.
Exactly. It's about privacy. It's about being sure that it's also responsible for managing node membership. So when a node joins, when a node leaves, got to be sure that the network is still secure in itself, because there could be a lot of potential attacks made if you allow for nodes to simply just join or leave the network.
Okay.
It's also about space management. So if the network has 1 million nodes, it would be extremely resource efficient if I had one node connect to 1 million other nodes. So it's very costly to have a new node join the network. Doing that much more efficiently and in a cheaper manner, that's difficult. And Kademlia, in this case, is a hardened version of the Kademlia protocol, which is used for managing BitTorrent's nodes. So BitTorrent uses Kademlia. We use a hardened version that has sort of evolved over the years that also IPFS happens to use as well.
Okay.
For managing the membership of nodes within WAVELET'S network.
Right. So essentially, it is about just effective node management. You've built it into Wavelet, and that's the big thing I think that I wanted to touch on to make sure that you had considered that. Now, with regard to the code itself, this is where I really wanted to get into this a little bit more and open up beyond Wavelet, because one of the things you have done in all of the work you've done in the last year is open source the code. The repos are all there. They're very robust already, but you've sectioned them off into things like noise. You've mentioned life already. Wavelet's there. Do you want to talk a bit about noise? We haven't touched on that yet as the networking stack.
Oh, okay. So noise, there's a whole load of things, especially behind noise, because there's also this sort of hedging going on between libp2p. Okay. So libp2p is another networking stack, and then afterwards, people are sort of comparing libp2p to noise, comparing noise to other networking stacks, and then everyone's like, "Why noise? Why? Like, what are the benefits of noise?"
Well, tell us why. You know, I mean, in a nutshell, because obviously of time. But if you could just let us know why noise exists in this architecture that you've built out.
When we sought building out wavelets, it's either that there were horrible P2P solutions available out there. In this case, we've tried libp2p very, very extensively, and the biggest problem is that it's a very strange network stack that got slowly bled or extracted out of IPFS's source code. It's like they built IPFS first, and then they took the networking bits and then sectioned that off into a new open source library. The problem with doing that, a lot of the networking functionality is more relevant to IPFS, not for general P2P applications. And there were tons of bugs that we had. The code was overbearingly complex. If you just want to start basic, just make a very simple P2P app where I have 10 computers, I want to network them all together. libp2p does not cut the bill. Right.
So too complicated, Band-Aid solution building from something else. So what did you do as a solution?
So we built our own, and Noise has gone through so much renditions to the point where actually currently Noise uses gRPC as a sort of transport layer at the moment, which is Google's remote procedural call stack for networking in this case. And we built, and basically Noise acts as a sort of extension to gRPC to provide all of the most important constructs needed. Message encryption, decryption, perfect forward secrecy, all of the cryptography, necessary overlay network implementations needed for P2P apps in general, peer bootstrapping, lots of stuff. Extends gRPC to support all of this to make gRPC effectively a P2P friendly networking stack. Because without all of those, gRPC has tons of number of security flaws that would basically break out a P2P app in this case. And on top of that, another reason, like why noise? The benchmarks, we've done extensive benchmarks. Actually, one of the biggest problems with benchmarking something like a ledger or wavelet in this case is the networking speeds are usually the bottleneck.
Okay. Well, we've seen that time and time again. Look at CryptoKitties as a perfect example.
Yeah. So, the internet's slow, and all of a sudden you think that, oh, maybe my ledger is only doing about 800 transactions per second.
Right.
All of a sudden, we faced that situation, actually. We were getting benchmarks of about 10,000 transactions per second. And then I sat down. It seems like the team over at Perlin was content, but I just sat down. I was thinking that there's something wrong with these numbers.
Right.
Most definitely, something's got to be up. So I was the one that started development of noise. I went all the way back to noise. And I took 8 different core networking transport protocol implementations.
Mm-hmm.
0MQ, Nano Message, MangoS, also libp2p as well.
Mm-hmm.
libp2p QIC.
To trial them all, I would imagine.
I trialed all of them. And under an extremely highly practical network settings, found out that gRPC was the fastest one.
Okay.
And then afterwards, I then tinkered around with gRPC, figured why was gRPC outperforming all of these like by miles? And then I looked at it; they had these sort of important elements needed for sending messages extremely quickly over a highly congested network, such as flow rate control, rate limiting, alongside framing protocol.
Right.
And
so you took the best of that, probably.
Yeah, took the best of it, built noise on top of it, and that basically led to the birth of noise, and also led towards Wavelet having 31,000 TPS.
I was going to ask you that next. So I'm glad you mentioned that. So the whole point of having this whole sort of interconnected web or suite that you've built is because it ultimately makes Wavelet more performant. It makes it what it is. So everything's really conditioned to build this out. So it again leads to that true and evidenced utility that we want to see, lead out. And it doesn't have to be Perlin, it could be anything. But the fact is you are Perlin and you built this from scratch. So it's quite amazing that you and your team have built this. I really mean that, Kenta. Now, what about Lens? That's another one with the TypeScripts. That's another aspect you built in.
I'm not 100% sure, actually, if you've seen the latest Lens.
No, I haven't.
Let me go get a little screenshot.
So guys, I just had a quick look at that. Kenta sent that to me. I haven't shown it on screen, but go ahead, Kenta. I've had a look. It's impressive.
Yeah, so basically it's a whole sort of web interface that basically lets you control a node. For the testnet / mainnet access, you'll basically be using Lens to then be able to deploy smart contracts, use smart contracts, transfer money to people, place stakes, withdraw stakes, do whatever you want. It's sort of your main control hub. And we took a lot of time to sort of, kind of design it, organize it so that it's extremely easy for you guys to basically interact with Wavelet.
Yep.
And just track your node's performance.
Now, with regard to, you said 2 interesting things before with clarify and certify, but there's some others as well with regard to some of those applications, because we want to still bring it to the real world. We can talk tech, well, you can, and I can listen forever, but we still want to see the point to this, the whole purpose of it. You also have Cloudify and other things as well. Build your own is another one. So you've got these applications that are just building. How many are in the pipeline? That's really what I wanted to find out more of, not just the fact that you've got these fundamental 4.
So we've mainly been in stealth, and as a result, like we haven't spread or developed the dApp ecosystem for just yet, but we're heavily going to be focusing on that in the coming future. Right now, we've got about 14 dApps in line at the moment that are being built. I'd still consider that a small number, but we're planning to. So before in my first year of university, which was about 2 to 3 years ago, I used to be the kind of guy that would go to hackathons. I've been to 20 different hackathons and I've won a good number of them. It's fun. Over in North America, Canada, MIT, Stanford. You meet a lot of crazy, amazing people there. So sort of resonating with that, we're going to be sponsoring a couple of hackathons around there as well. And actually, sort of set up topics, set up prizes for people to go for developers who are extremely passionate about just developing new tech. We implore them to use Wavelet, try it out, create some amazing dApps using it, and we're going to be providing all the assistance we can for them in this case.
Awesome.
And the best ones, well, they'll get some pearls denominated and a couple of extra swag in this case.
Saw that. We saw that with the city of Zion when we saw Neo initially in its heyday when it was trying to build out the ecosystem. So they had this grassroots initiative led by them. So you're doing something a little different, but with the same concept. But let's translate that though to the top down approach as well, because we've seen Algorand come out with a very different approach in that respect. Now, are you also going to incentivize the big boys, you know, with the big money to come in and build things on Perlin as well.
Mm-hmm. Yeah. In that case, it'd probably be best for Doji to sort of explain on the enterprise side in this case. And, you know, there's going to be another talk on that coming soon, either way.
Now, I promise you that I will definitely be on the phone to Dorji to find out, because he's, having spoken to him before, he's very much enterprise centric. You know, he's all focused on trying to gear the blockchain to the masses. So there has to be more than just these grassroots hackathons. I'm sure that you're not telling me some stuff there. Now, with regard to, you know, the whole adoption, that's the big buzz for you. You know, you might be the technologist, you might be one of the world's best, but you definitely want this to be real. So what's the vision from now on, let's say just until the end of the year, with everything you've done? You've got mainnet, super exciting. And I'm sorry I'm not more animated about it. It's a big deal. But now that it is, what's the plan for the rest of the year, Ken? Like, what are you going to do?
We're basically going to start cultivating the entire dApp ecosystem. And that's not going to be an easy feat, because we've seen Ethereum doing it for large, long years.
Yeah, that's true. But you've got something faster.
Exactly. Faster, easier to use. But the whole point is that it's hard to attract the developer mindset. Most definitely. You've got developers, whether they, you know, you got developers who are gamers, developers who are into memes, and then you got the enterprise developers and the ones who do it as a job. Getting that sort of mind share, get into the decentralized ecosystem is crazy hard, but you know, the reason why I'm in it.
Or how do you do it? Because we've been talking before, you're in many groups as a developer, as a technologist, you have all these different subgroups. Now, that is almost in itself, you know, families of us and associates and colleagues. How do you get people to transition that into that narrative through PR? You know, how do people come
Exactly. Right.
So
for the marketing PR approach, a lot of people say that, claim that if you don't have anything extraordinarily new, developers won't come for you. That is actually completely wrong. Actually, developers are more of the sort of mindset, from what I've seen, that just don't accept bullshit.
Well, that's good.
And to be honest, you know, the crypto community, when it comes towards technology,
there's a lot of BS.
It's a load of bull.
Yeah.
So, you know, if there are people claiming a million TPS, there's no proof. There are people claiming, hey, it's easy to develop smart contracts. It gets confusing. When I want to develop a smart contract for Ethereum, I go on a website called Remix, and then I somehow type code in there, and then I can't just use the tools I know and love.
So number one, you're saying is code is king. Ease of use is king. Practicality, seamless experience, quality of code, all those things you build. That's going to resonate with the developer, and that's how you're going to get them across.
Not just that, but the fact that for developers, we're being very rational with them. So basically, Wavelet, the whole cryptocurrency space to them is, all right, they get the idea. It's cool. The problem is, it's what applications do I actually build out of it? You know, you've got, if tech people, the ones who build a lot of products and services today, can't figure out the use cases immediately popping up in their head without studying tons of finance or reading tons of papers about it, that's the problem. It's just something that doesn't have clear vision yet. And that's because currently blockchains have low scalability or poor security, or haven't really been stress tested in real world applications. For us, we're basically giving them table stakes. So we're giving them table stakes, showing them, hey, blockchains are actually scalable now. Hey, it's actually easy to run one on your computer. You can use all the tools you know and love. You can go about looking at the source code. You can even choose to contribute to it if you want. And most importantly, you know, it gives you tons of advantages of building products and services on top of Wavelet compared to, say, just building it for the web.
Right. And
so give those kind of table stakes. It's just rational.
Thing miss that I think is the number one reason why people want to try it is because it's going to make them some pearls. And that's monetized. You know, that's the reality, is people are still driven by this point that it's a monetized economy. I mean, it's tokenized and has monetary value. You know,
most definitely.
So I think that's going to be quite revolutionary for those people who don't have access to a lot of money. You know, we're talking about disadvantaged regions of the world. This is a really big deal. I was talking to Georgie about this and his whole incentive, because he could, as we've talked about, he could retire and not do this, but he's doing it for something bigger than himself. Now that, again, you know, that leads into the plan and the roadmap for access. Now, you can't
Right.
answer this, so you could just pass. But right now, you are coming out of stealth. Mainnet is today. That means native token. That means exchange is coming sometime. So what's going on
Mhm.
there? When will people be able to start to interact in the ecosystem of exchanges?
You know, I say this even in the Discord chats or the community chats. There's not even a tentative date yet, but I can most definitely tell you that it's going to be soon.
Okay. Okay. So soon. So capital S, double O, N, soon. Now, you've mentioned
Soon.
some partners. What was impressive, again, not trying to FOMO, is I've seen Dorji all around the world, Brazil, Paris, making big announcements, Chamber of
Mhm.
Commerce, big, groups of people that are not in the crypto sector.
Yeah.
Why is he doing that? What is in his head? He must be thinking pretty big.
Well, that whole, $8.7 billion of paper wasted every single month for trades, you got that all on a blockchain now. And you've got trades being automatically settled and finalized, not in 2 weeks, but in less than a couple of minutes.
Right.
That's sort of the big idea. A lot of politics nowadays, it's still extremely slow, extremely cumbersome. A lot of trades, a lot of the policies, the logistics behind how the world works today, even for the big commercial banks all the way down to Wall Street. Um, they're horribly inefficient processes.
Absolutely.
So
It
on
sounds
the
like
enterprise sector,
he wants to
that's
change
where
all
we
of
come
that.
in.
Right.
Exactly.
And Kenta, it's been an absolute privilege. We could have talked for a lot longer, and we hopefully will again talk. But for now, I want to say thank you to you. You are the lead researcher, the lead technologist of Perlin. You have been doing an amazing job, a stellar job with regard to building out this whole architecture, this suite of tools that goes from Wavelet right across. For those who don't know, please have a look into Wavelet. It's a very complex, innovative system. It's something that Kenta has dedicated a lot of time to. And on behalf of those who are just proponents of trying to bring utility into the space, thank you, Kenta, for all the work you've done. This was an entirely free interview. I do want to also make sure people are aware this is a speculative industry. Crypto is not something for the faint-hearted, but beyond that, there's blockchain, and that's a very different conversation. And that's what obviously Perlin's all about, is trying to bring blockchain to the masses. So thanks again, mate. Keep going with it. Don't give up, and hopefully we can catch up soon.
Most definitely. Yeah. Pleasure's mine.
Likewise.